height, and this is radius, and this is height. Wikipedia, or Google, I guess, is telling me that the area of the outside part is pi times r times the square root of h squared plus r squared. Okay? Which in this case is just going to be pi times r times the square root of 2r squared, which is square root of 2 times pi r squared, which is exactly what we got. Pi times 9 times root 2. So as far as why that square root of 2 is the proportion of this thing that we cut out, don't know. Again, I'll see if I can find out by Monday. So, because that seems like an interesting sort of elementary school experiment that ought to be fruitful in this case. All right. Yeah, teach me to prepare for class though. All right. So, what's something that we can actually recognize? What's something that you know the surface area of? You know the surface area of a sphere? It's 4 pi r squared. I think so. So let's try that. That's the surface of revolution. Might be harder than this one, but let's see.
Is 4 pi r squared or 4 pi r cubed?
4/3 pi r cubed would be the volume. I think 4 pi r squared is the surface area. It looks like the derivative with respect to r of the volume, because basically you're taking a tiny bit of volume. You're right. It's a change in volume with respect to radius. So it should be 4 pi r squared. Let's see if we get the same answer here. So I got a circular radius r. This looks like the one that came up in the lab, right? This is y equals plus or minus square root of r squared minus x squared. Is that right? Just because x squared plus y squared equals r squared is the equation of the circle. So I'm going to use the positive one because I'm going around the x-axis. Okay. And what else? Alright. Well, I need surface area is the integral from what, negative r to r probably? Okay. It's supposed to be 2 pi times some kind of a radius times a small amount of arc length. Okay. Now 2 pi I can take out. What is the radius going to be for our purposes here? It's that distance, right? Because the distance from the curve to the outside. So it's going to be the same thing as our y coordinate. So in this case, our radius is square root of r squared minus x squared. Okay. This is going to turn into square root of 1 plus dy dx squared dx, like it usually does. All right. So I got 2 pi times integral from negative r to r, root r squared minus x squared. And this will be 1 plus, I think we did this calculation last time for circumference of a circle. Let's see, if y is r squared minus x squared to the 1/2, what is dy dx? Should be 1/2 times this mess to the negative 1/2 times negative 2x, is that right? Okay, so 2's cancel, and I get negative x over square root of r squared minus x squared. And so in particular, what I've got here is 1 plus x squared over r squared minus x squared. So it'll be cool if some stuff canceled out. This is 2 pi, negative r to r, square root of r squared minus x squared. What am I gonna do inside here? Yeah, common denominator here. So r squared minus x squared on top and bottom. So I've just got r squared on top, the x squared's canceling.
Can you combine the radicals?
What's it?
Can you combine the radicals?
Sure can. Do you see where these two things are gonna cancel out? So really what I've got is r over this dx, and look at there. All right, I've got 2 pi times the integral from r, negative r to r of r dx. Didn't expect that. All right. What's the integral of r dx? Yeah, it's rx, not r squared over 2. Remember, I'm not integrating with respect to r. R is a constant. So it's an easy trap to fall into. So this is rx, evaluated at negative r and r, which is 2 pi times r squared minus negative r squared, yep, which is 4 pi r squared. Cool, all right. So the surface area of a sphere, the hardest thing about it was just getting the derivative of the circle function, but that's it. Now the place I can see this getting ugly is, think of the situations where we had surfaces of revolution that we were finding the volume of. We didn't always just go around the x-axis. We might go around the y-axis. We might go around the different axes, right? So let's do some of those kind of problems. All right, so suppose we revolve the graph y equals x squared around the y-axis, and let's say that x is in 0 to 3. Okay, so first of all, what is this thing going to look like? There's a parabola. Now if I revolve this thing around the y-axis, coming around this way, got that. So what I'm going to get, like a bowl, right? So I've got that kind of thing. So I'm finding the surface area of this soup bowl here. All right. So in this case, I know my surface area is integral from somewhere to somewhere. It's probably going to be 0 to 3. What I want is 2 pi times a radius times a small amount of arc length. And I know arc length is going to look like 1 plus something squared under a radical dx. All right, so what normally goes here? dy dx? Okay, so what I've got is y is equal to x squared, so y prime is equal to 2x. That's what goes in there. The big question I've got for you is, what's my radius going to look like? Do you see where it's not my function value this time? Because the radius is the distance from here to here. So if I'm integrating with respect to x, what is that?
So y equals x squared, x equals square root of y.
X does equal the square root of y, but there's no y's in here. I'm integrating with respect to x. That's it, right? Can you see where it's kind of like what you run into in cylindrical shell method, right? My radius is actually just my x coordinate. So this is the way that I think about it, because a lot of people have a hard time with this, is they want to put a function of y in here because it does go over to the function, right? So how are we accounting for that? Well, we're accounting for that because we're integrating with respect to x. The place the y shows up is over here. So if you're measuring a horizontal distance, you know it's an x distance. Since we're integrating with respect to x, that means it's just going to be a variable x. If we were integrating with respect to y, this would still be an x distance, but then I would have to convert it over so it's in terms of y. So I'll do an example both ways. All right, so, and this is actually going to be way easier to integrate. Remember when we did arc length of this curve last time and it was horrible? Because it was that, we ended up with like secant cubed, turned into that mess. Why is this easier?
Oh,
Yeah, that's a square. Yeah, this is an easy use of, right? So, let's see. If I do u equals 1 plus 4x squared, that means du is going to be 8x dx.
why'd you change your upper integration now?
Do what now?
The upper integration limit?
I don't know. Doesn't make any sense. Yeah, no, it's still 0 to 3. Yeah, sorry about that. Friday morning brain, that's why. So, what I've got is an x dx, and so it means I'm going to have to divide by 8, right? 1/8 du. So, yeah, thanks for calling me out on this. I actually need this. So, yeah, there's nothing worse than watching 25 people blindly copy down something that's obviously incorrect. You know, you gotta call me on this. So this is the integral from somewhere to somewhere of 2 pi over 8 times u to the 1/2. You want to change the limits? Probably wouldn't be too bad. So when x is 0, what's u? 1. And when x is 3, 4 times 9, so 37? Okay. So I'm integrating from 1 to 37. This
You want to
thing.
change the integration limits when it's a u sub, right?
Yeah.
Okay, that was confusing on my homework. I couldn't figure out where that was coming from.
Yeah. When it's a substitution in general, you can do these sometimes with trig subs, but
I only covered that like in the first week or 2 of class, and I already got it.
yeah, no, I know what you mean. If you miss something early on, it's hard to find it. Yeah, but yeah, no, that's all we're doing, switching the limit. So what I've got out front is a pi over 4. All right, now if I integrate u to the 1/2, that is what, 2/3 u to the 3/2, and that's happening at 1 and 37. Now 2/3 of pi over 4 is what, pi over 6? That I can factor out, and then I should have 37 to the 3/2 minus 1 to the 3/2. You might see this written as pi over 6 times 37 square root of 37 minus 1. So there's a surface area. So in general, places where arc length is horrifying, surface area is not that bad. All right. So suppose we try a different one. So okay. So y equals square root of x between 0 and 4. And I'm going to go around the line x equals -1, and I want to find the surface area of that. There's probably 2 ways you can do this. Alright, so square root of x